Okay, so an example. This is an example where I'm going to show you how this example could be a permutation and how this example could be a combination. So it's part of a grade 12 English class course, I guess. It's part of a, that's part, even though it does not look like it, of a grade 12 English class. Course. Students are required to read 3 books. Bless you. In a 3-month period. The Grapes of Wrath. The Wars. And the Bean Trees. Written by me. No. No. Thanks for the vote of confidence. A. Due to previous late returns, Ben is only allowed to sign out 1 book at a time. How many ways can he do this? Okay. So is this a permutation or a combination? Does order matter when you pick out the books? You're taking 1 book out at a time. What if you really want to read the Bean Trees first? Well, then you would want the Bean Trees first. Order matters. You can't take them all out at the same time. Order matters. If you could take them all out at the same time, order wouldn't matter because I get all 3 books and I could read them in any order I want. But if I really hope to read the Bean Trees, the librarian has a chance of giving me 3 separate books. So order does matter. It's the permutation. How many options do I have for the very first book being handed out? 3. And then the next one? 2. And the next one, 1. So actually, I can take these books out in 6 ways. So it's a permutation. It's asking you how many different ways can she pick the books out. So the first time she could pick out 3 different books, right? She could pick out The Grapes of Wrath, The Wars of the Bean Trees. If you're saying order doesn't matter, then she could just get all the books at once, which she can't do because she is forced to only take out 1, right? So the first one she takes out could be 3 different books. But now she's read that book, she's not going to take it back out again. So now there's 2. Read one of those books, and then there's 1 left for the 3rd month. B. If he, and I said she, but it's not a she, it's he, it's Ben. If he can take the books all out at once, take the books out all at once, how many ways can you do this? If you can take the books out all at once, how many ways can you do this? How can you check the books out all at once? Once. Goes there. I want all 3 books. She checks out the 3 books, hands them to him, he puts them in his backpack, and he goes away. It's a combination because the order in which he gets those books doesn't matter. He gets to take all 3 with him. So they're either in his backpack after he gets them from her or they're not, right? So it's a combination because the order doesn't matter. It doesn't matter if she signs out Grapes of Wrath first, then the Wars, then the Bean Trees. She signs them out, puts them in a pile, he grabs them and takes all of them with him. There's only one way he can do it. He just signs them all out. And it's a combination. Now, the other way we could write this is we could go 3. He has 3 books. It's a combination because the order doesn't matter. 3, which is one way as well. Now, check in your calculator. Let's plug this in. How do we plug that into our calculator? We go press the button 3 to get the first 3. Then we go math over to the left to probability. And we pick number 3, which is NCR, because we want the C. And then we press the 3 button again. So that we get 3. This gets us the C, and that gets us the 3. So try it out in your calculator, 3C3. One. Okay, now it says NPR or NCR, whatever it may be. We use NPR if it's a permutation, sorry, and NCR if it's a combination. So this one would have been 3P3. Put 3P3 in your calculator. Try it out. This one I had 3 books. It was a permutation, and I picked 3, right? Because it's doing the math for you. You have 3 books, and you're choosing 3, and it's a combination. Now, the catch is, please pay attention and stop talking. This is why I don't record your class. I'm still recording this, which is fantastic. But anyways. No, you're fantastic. You're fantastic. Okay, the catch on this one is you have a number and you're picking a number from it, right? Or a number and you're choosing a number from it, whether it's permutation or combination. So can I say 3 books, but I'm picking 5? Does that make any sense? No. So the catch here is that N has to be greater than or equal to R. N has to be greater than or equal to R. Because N can't be less than R because you're picking that number from it. The other thing is NCR on your formula sheet shows you this, brackets NR. So it can be written like that as well. So instead of 3C3, 3C3 can be written as 3, big brackets. And it shows on your formula sheet. It means 3C3. It's on your formula sheet. Example. Don't test it. 10 students on the skating committee. There are 10 students on the skating committee. So these 10 students on the skating committee, A, how many different 3-person subcommittees? How many different 3-person subcommittees are there if you select three people to be an organizer, team leader, or a fundraiser? So you have 10 people on this committee. How many different 3-person subcommittees are there if you select 3 people to be an organizer, team leader, or a fundraiser? So does the order in which you pick these 3 people matter? So if you're picked first, you're an organizer, but you really want to be the fundraiser, does the order matter? Yeah. When you give jobs to the people in the subcommittee, order matters. Because if you're picked first, you get a certain job. If you're picked second, you get a certain job. If you're picked third, you get a certain job. So you have something different to do depending on which way you're picked, right? Order matters. Order matters, the permutation. So whenever they have specific jobs, whenever you have specific jobs to do, it's a permutation. So how many people do we have to choose from? 10? Do you pick a P or a C? P because it's a permutation. How many people? 3. So 720. It's easy if you know it's permutation. So remember, if these have specific jobs, then it's a permutation. Now, how could I ask it in the way that it would be a combination? B. How many different three-person subcommittees are possible? So when deciding if order matters, you're looking at the people that you're choosing. And if those people that you're choosing, those specific people, if the order that you choose them doesn't matter, then it's a combination. So we have a 3-person subcommittee. So if you're picked first, you're on the subcommittee. If you're picked second, you're on the subcommittee. If you're picked third, you're on the subcommittee. Does it matter what order you're picked? If you're picked third, are you any more special than if you're picked first? No, you're just on the subcommittee. So if that's the case, it's a combination. Order doesn't matter. Of those 3 people you're picking, does it matter if you're first or third or second? No, you're on the subcommittee. You're no more special than the other person. So it's combination. So the only thing that changes is a C. So 10C3, or I could wrote it like this, 10 and 3. And 10C3 is 120. Why is it so much smaller than 10P3? Put your hand up if you have a guess. Why do you think 10C3 is substantially smaller than 10P3? P is a permutation. Order matters. So the way you pick those 3, order matters, right? So if you pick first, second, or third, it matters. With a combination, you divide out those triple ups because it doesn't matter if you're first, second, or third. That group is the same as if you picked that exact same group the other way around. So if the group had Emma, Jade, and Sabina in it, and I picked Emma, Jade, Sabina, or I picked Jade, Emma, Sabina, or I picked Sabina, Jade, Emma, it's the same subcommittee, right? Because they don't have any specific jobs. So those 3 that I picked would just count as the same option, right? The same subcommittee. However, if I picked them up here, it'd be totally different. If I picked Sabina, Jade, Emma, they'd have different jobs. Or Jade, Emma, Sabina, you'd have different jobs again. So then you're going to get more ways to pick them. Does that make sense? Okay. Example, no. HTA is planning a trip to the zoo. Five teachers want to go. And 10 students. However, due to the amount of room on the bus, bus, only 2 teachers can go, only 2 teachers and 5 students can go. How many ways can this happen? HTA is planning a trip to the zoo. 5 teachers want to go and 10 students. However, due to the amount of room on the bus, only 2 teachers and 5 students can go. How many ways can this happen? Now, is it a permutation or a combination? Let's think about this. Let's think about this. Picking 2 teachers. If you're the first teacher picked or the second teacher picked, are you any more special? No, you get to go to the zoo or you don't. 5 students, those 5 students you're picking. If you're the first, the second, the third, the fourth, or the fifth student, does it make a difference? No, so it's a combination. It only matters on the people that you pick. If the people that you're picking, that you're choosing, if being the first student chosen or the second student chosen is different, then it would be a permutation. So if these students had jobs on the bus, or these 2 teachers had different jobs when they went to the zoo, one counted the kids on to get off the bus and one counted the kids to get on the bus, if I gave those 2 jobs to them, then the order of picking the teachers would matter and be a permutation if you give them jobs to do. It would be 5C2, because the only way you can guarantee teachers is by choosing them from teachers, okay? And then we want 5 students, so we do 10C5. Now our question is, to go to the zoo, do we have 2 students or 2 teachers and 5 students going, or do we have 2 teachers or 5 students going? Is it or and? And. So if it's and, if it was or, that would mean you only had the teachers or the students going. You couldn't have both, which doesn't make sense. And means we do what? So try it out. Okay. 2,520 is the answer. Now, the next example is cards. Now, if you're given a card question on your test or on the diploma, they have to lay out what the cards are. So like, for example, a deck of cards, like I did on the last test, I gave you like the picture of all the different cards and the colors they were. That's what they would have to do on the diploma. Or else what they do to make it a fair diploma for you is they'll make a completely different deck of cards that no one's ever heard of. So they'll say the deck of cards has 20 cards in it. There's 4 suits, pink, blue, green, and orange, and numbers, blah, 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 okay? Like they'll give you your own different deck that no one else has seen. So that's what they'll do. But we're going to look at cards. Now, cards are always a combination because when you pick the cards, the order doesn't matter. So, for example, in poker, you pick 5 cards, right? Now, does the order of those 5 cards matter? If you're picked first or fifth of the cards, does it matter? No. You're either in the cards are either in your hand or they're not. Okay? Once the cards get in your hand, can you move them around? Yes, so the order doesn't matter. Because if I get this card first, I can move it over here and move this one over here, move this over here, move this over here. Cards are always combinations, unless you played a game where they said the way you got the cards in your hand, you had to lay them down in that exact order, then the order would matter, because if this card had to stay here, well, then you had to lay it in that order. I've never played a card game like that. So cards are always combinations. So let's go over what's in a deck of cards. So there are 52 cards in a deck. There are 52 cards in a deck. How many suits are there? 4 suits. There are hearts, diamonds, spades, and clubs. Hearts and diamonds are red. Spades and clubs are black. Half the deck is red, half the deck is black. If there are 4 suits and you divide the deck into 4, there are 13 cards of every suit. Half the deck is red, half the deck is black. Unless you know cards really, really well, you want to write these rules down because you're going to be doing homework on them. So if you do 52 divided by 2, 26 are red, 26 are black. Face cards, what are face cards? Jack, Queen, King, the cards with faces on them. So the Jack, Queen, and King of every suit are the face cards. There are 3 face cards per suit, so there's 12 face cards. The cards go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, except the 1 is an ace. It has a little ace symbol on it. All right? And Jack, Queen, King. So, we're going to go through some questions. Choosing a 5-card hand. A. How many 5-card hands can you choose? Five-card hands can you choose? Now, we know it's a card, so it's a C. How many are you choosing? 5, so we're going to end in a 5. But what little subscript number are we going to put in front? How many cards do we have to choose from? 52. There's no specification. It needs to be a queen or a heart or a spade or a red or anything. So we choose all of them. So this is the maximum amount of 5-card hands you could get in poker. So it's 2,598,960. So in order to, you could sit down and play poker for the rest of your life and never get every single card or every single hand possible. For example, like it's the exact hearts, 2 or 3 exact hearts and 2 exact spades. You might get 3 hearts and 2 spades, but it might not be the exact same 3 hearts and the exact same 2 spades, right? Because there are 2,598,960 combos. Like you would have to, it would take you a long time and probably not going to happen. The probability would be very low. Now, that's an easier question. But what if I ask you this? So choosing a 5-card hand, how many are all diamonds? So it's the same deal. We're still choosing 5 cards because we need to choose 5 cards. And we can choose them to be all diamonds because we have more than 5 diamonds in the deck, right? But the only way we can guarantee getting diamonds is choosing from diamonds. So how many diamonds are there? 13. So we dropped from 2,598,960 to, of those cards possibilities, we have 1,287 different types of possibilities of getting all diamonds. So it's still quite a few, not nearly as many out of the whole deal. C. How many have 4 black cards and 1 red card? It's possible to get 4 black cards and 1 red card. How many 4 black cards and 1 red card? So we need to choose 4 black. How do we guarantee getting black cards? By choosing them from the black cards. How many black cards are there? The word in between this is 4 black cards and means what? 1 red card. So we're going to choose 1 red card from how many red cards? 26. D. What if I said now 3 kings and 2 queens? You try it. 3 kings and 2 queens. All right. We're choosing 3 kings from how many kings? 4. There's 1 in each suit. The word and means multiply. We're choosing 2 queens from how many queens? 4. There's 4 of each of them. So that gets me 24. Now, everyone seems to do okay up to this point. Then I do this one and people make errors. So, 4 aces. What people do here is they do the 4 aces correctly. They go, I have 4 aces, I choose 4 aces. They tell me that's 1 ounce, that's 1 way, and they move on. That answer will be on your test, 1. 1 will be an answer that will be on your test. It's not correct. Because how many cards are there in this hand? 5. And we didn't actually, we're not finding 5 right now. They said 4 aces. So instead of writing 4 aces and 1 non-ace, they just wrote 4 aces, and you need to know that the other one has to be not an ace. First off, it couldn't be an ace because there only are 4 aces in the deck. Second off, it can't be an ace because they want exactly 4 aces. Okay, so this one couldn't be. So it's 4 aces and 1 other. You need to remember to write that. So it's going to be 4C4 for the 4 aces and multiply and 1 other. It has to be other than an ace. So how many cards are there other than an ace? 48. Because you do 52 cards minus 4 aces. So it's going to be 48, choose 1, which is 48. Try this one. Two kings and 1 5. Let's try that one. And G, 3 kings. Okay. For this one, it says 2 kings and 1 5. The catch on that one is that still only totals to 3 cards. I need 5 cards. So 2 kings, 1 5, and 2 others. 2 others are 2 cards that are other than the 5 or the king. I can't count any 5s and I can't count any kings. Yes, I'm only using up 2 kings here, and yes, I'm only using up 1 5 here, so I still have 3 left and 2 left, but I can't use those because I could chance then getting a 5 or another king, and I only want 2 kings, okay? So I have to exclude them when I look at the others. So how many kings are there? 4. I choose 2. And how many 5s are there? 4, and I choose 1. How many others are there? 44. Because you have to exclude the kings and the 5s. How many kings and 5s are there in total? 8. Not the 3 that you took. There are 8 out of the deck that are kings and 5s. So you have to exclude those out. So 52 minus 8 is 44. Choose 2. Mm-mm. So this is going to be 22,704. Now the 3 kings, it has to be 3 kings and 2 other cards than kings. So I have 4 and I choose 3 for the kings, and is multiply. How many cards do I have left that are other than kings? How many? 48. Because you're going to take 52 cards and you're going to take off all the kings, and there's 4 kings. So you take them all off and we're left with 4. I know we only chose 3 of the kings, but we have to take off all 4 kings because we can't get another king. If we keep that extra king in the others, we chance getting another king, and I don't want another king. I only want 3 kings. So I go 4C3, and then I take 52 minus off those 4 kings, so I don't have any left. And I have 48 other cards that aren't kings. Choose 2. And you get 4,512. So I can give you an example like this where I give you something with 6 vertices. I could say it has 6 vertices. I can't say it has 6 sides. I can draw you the figure. And I can ask you, how many triangles can you make from that shape? Now, how many vertices do I need to make up a triangle? 3. So let's say I make this triangle. I have to decide, is it going to be, I have 6 vertices and I choose 3 at a time, so C, or is it going to be 6P3? So we have to decide, does the order in which I pick the 3 matter? So if I pick this one, then this one, then this one, do I get the same triangle as if I pick this one, then that one? Yeah. Yes. So does the order in which I pick the 3 matter? No. So it's 6C3, not P, because the order doesn't matter, which is 20. So you have to remember, it's those numbers, it's those things, it's those objects that you're choosing. Does the order in which you pick those matter? So these 3 vertices that I'm choosing, if I pick which one, the one first and the next one second and the next one third, did it make it any more special? No, it still makes the same triangle. So that's what you have to decide. The number that you're picking, if I pick those in a different order, does it change it? No, if it doesn't change it, it's a combination. I could not grasp that in high school if someone paid me. It was just something I couldn't get, and I would guess P's and C's the entire time, which is brutal. Don't be that person. It's not very productive, and it also gets you a really bad test mark. Trust me, I had a really bad test mark. But I didn't ever understand that it was the objects that you pick matters. It doesn't matter. I always thought of it this way. I always thought, oh, the first 3 objects, but if you're the 4th one, you're not part of it. So order does matter, because if you're 4th, you don't exist. You don't get to, that's not how it is at all. It's the objects, the 3 objects you pick. I always thought it was like all of the objects. Well, if I'm the 4th one and then I don't get picked, I'm not happy. This is not good. So I would be like, that no order matter. That's how I did it. It is wrong, is terrible. Do not do the Lepp method of the old, I was Wagner back then. Do not do the Wagner method. It was bad, and it made me fail at that unit. Always. Single tier. No, I'm okay. Last example. Last example. There are 5 teams in a hockey tournament. Every team plays each other twice. How many games are played? So you have to decide, does the order matter? The 2 in which you pick. So I'm going to pick 2 at a time. People are like, well, it doesn't say anywhere on there that you pick 2. How many teams play each other at once? 2. That's why you're picking 2. You're picking 2 teams at a time to play each other. If it's baseball, it's 2 teams at a time. If it's soccer, it's 2 teams at a time. If it's, I don't know, tennis, it's 2 people at a time, or I guess 2 sets of people at a time. So we're going to pick 2 for hockey because 2 people play at a time. Now, I'm going to do it as a combination because what I'm going to say is the order in which I pick those 2 doesn't matter. So I'm treating it like there's no home and away, right? I'm just picking 2 people to play against each other. So I have 5 teams, and I choose 2. Now, if I take those 5 teams and I choose 2 to play at a time, that will get me what? What's 5 choose 2? 10. So I want them to, every team to play each other twice. What does this represent? The number of games played if they play once, right? Just 2 teams at a time play each other out of the 5. So I get 10. I want them to play each other twice, so what do I need to do? Times by 2. If it was 3, times by 3. Okay, that's 20. That's why it's 5. Choose 2 teams at once. You're choosing 2 teams at once. You're not choosing yourself. It would be like HDA playing the comp. That would be 2 teams. Who are the B? HDA, comp, a team that starts with an A and a B and a D, because I'm lazy. Okay, so you'd have H play C, you'd have H play A, you'd have H play B, you'd have H play D, right? Now you could have what? Play A, C play, but C can't play H anymore, right? And C can't play C. Okay, what else is there? A could play B, but B can't play C, already it is. B can't play H, it already is, but B could play D, and that's, you got every, what else are we missing? A can play D. C, D is already done. So there's your 5. You're not counting yourself, playing yourself. That's not 8 games, that's 10. Hayden said, why couldn't we just do 5P2? You can do 5P2 and get 20. That works if they're playing each other twice, because what you're doing is you're counting one team is home and one team is away, and then you're swapping them, teaching one is home and one is away, the other way around. So that's why you can do the P, but that only works with twice. If it's 3 times, what are you going to do? 5C3 times 5C2 times 3. You're still only playing 2 teams at once. Even if I say they're playing each other 3 times, you're still only ever play 2 teams on the ice. That is super strange if you're throwing out 3. Still 2.